everybody, welcome back to Minetech, the only series that's named after a server, which it wasn't intentionally, has 0 servers in it. I'm very, very angry about that, but I won't repeat it for any other episodes. But in this episode, we've got quite a lot to cover. So I just realised that I forgot to do one of my vital things in this series, is to do a plan. So let's get started with that. So I'm gonna call it greenstone and use emeralds, cause yeah, redstone, greenstone, get it? But yeah, I'm gonna move my screen. So first off is the user interface. This is where you control everything and press all the pushy buttons and stuff. Then from that it splits into input register alpha or A and input register beta. I want to sound professional, but yeah. And then these two will link up again together and go to your ALU, not LU, ALU. Forget that, it's ALU. Okay, I'm just ALU, and this just does all your functions and mathematics. And so then the ALU goes two places. It goes back to the input registers. Well, both of them, to be honest, but yeah, I don't have time. So say you want to do 4 plus 2. 4 plus 2, that equals 6. No, it doesn't equal 6. And say you want to do 6 plus 4. You take your 6, go right around back to one of the registers, add your number you want to add to your previous answer, and repeat. But yeah, it also goes to your RAM, which is the only component we've built so far. Progress! Yeah, I'm kind of worried, because you only built one component, and it's already the 3rd episode, so I'm pretty... yeah. And this RAM also goes back to your input registers. Both of them, yet again, I haven't connected them because I'm a lazy bastard. So after that, it goes to your dreaded graphics processing unit, which will actually display the damn thing on screen. And yeah, I know how to build these, but graphics card, if you know about that stuff, NVIDIA, they are expensive, they are complicated, and replicating one of mine, they're also big, one of the biggest things in your PC, apart from your power supply. I mean, if you can get a Corsair 12,000 volts AXI, that's big. But yeah, so graphics cards, they're huge. On Minecraft, it's gonna be pretty hard. I think I'll have to build it into the screen or something. Quick command. Oh wow, yes, I'm very, very good at typing. Okay, sorry about that. And so, and then I'm gonna have this bolt on the screen. But we're going to need also an operating system, which I'm going to have quite a lot of pain to be doing. I'm going to have to code it in binary. I've done Java, Python, I've done a bit of Ruby, HTML5, but I have not done binary before, so this is going to be quite hard, and on Minecraft too. And so I think it's going to be like a terminal style thingamajig. What should we call it? Greenstone OS? No, Atticus OS. That sounds stupid. But moving on, we've also got these two little fellows here. This is your program memory, and this is a bit complicated what it does now. Alright, so I built a little demonstration here. So let's say these are your commands. These strips of redstone that are featured in your ALU. The program memory, readable lines of ROM, which is read-only memory, and so which will also remember what these guys do and tell them what to do stuff. I think, yeah, it will only tell them what, forgive me, it will only tell them what to do, because it's read-only, you can't write on it, ROM. So, and it'll go to your clock, which is probably the simplest bit. If you know a tad about redstone, you'll know what a clock is. So what it'll do, it'll tell it, if it's a 5-tick clock, which is 1 tick is 0.1 seconds, so every half a second, it'll go through this line, then this line, then this line. The faster the clock, the better, because then you can give your commands more memory. But if you're using quite a lot of repeaters, it may jam up the system and keep it constantly on, which will not be very nice. But forgetting the blueprints or schematics. Yeah, this is more of a schematic, not a blueprint. Because blueprint shows you all the parts. Schematics are like how it basically works with all the wires. This is what I've been really excited about. This is quite a lot of memory storage. Command blocks, the dreaded command blocks. So what is in here? Well, a book and a quill. And these little, let's call them commandos, can actually write in the book. Can write in the damn book. So I've been testing this. Nope. So 10. That's all it's done. Don't sign the book, because then you won't be able to read it. So what's going to happen is your processor is going to be like, and it's store information. So if it's going to be a binary on, it'll go into this one, or binary off, which I'm not sure is going to work, because it'll be off, because there won't be any redstone signal. I think I should use like a flip-flop gate or something, into 0. And then, when you want to read it, some more signals go here and see if there's a 1 or a 0. If there is a 0, signal will come out of here using the trusty comparators. But when I was trying this with a computer that I haven't built called Bluestone, that one of my friends has built, it did tend to jam because the redstone signals. So say you pressed right, read. Maybe the right goes a long way around lots of repeaters and then goes into this little block. It'll go in before the read, so you'll get the information that you put before and screw your whole system up. And this is simply solved by making it a bit more compact and adding these. For you who don't know, if a comparator is getting power from the side, it's all become locked, and I do not have any redstone in my inventory. Pig block. Oops. So what's all this happening? You can still flip it out. I think I might have broke the system. Excuse me while I try to fix this example. Right, so here what we have is that a locked repeater. You can still edit it, but it's locked on the signal it is receiving. So right here, it is receiving the signal, but it is locked, so it won't until this signal has ended, which it can then broadcast its information, or in our case, the signal that says write. So I've been playing around with this. This is a binary test. I used the Bluestone again, and this is supposed to, it does broadcast a little animation. Well, it's very simple. It's just a pixel going around. You got 2 pages, which I've fitted quite compactly, as you see. It is very complicated. And then this is the weird bit. So I put in the command block to say command end, and then this stuff, and then right. So it says command end, and then disappeared. And I was like, what the hell? And I'm like, oh, and so what it's saying is that it read this, and it's not 1 or 0, so it says error number 23, which is an identifiable numeral. Yeah, so trying to get it end actually creates an error, which isn't too important for now. But it will quite a lot screw some stuff up in the future, which I'll have to fix that. But anyway, here we got another example with quite a lot of hoppers, which is this would be like a bit like a CD drive or a ROM. This is a read-only memory system again, which we've scrapped the whole write bit so it can only read it, much more compact. And so you just throw in your book here, or our floppy disks I like to call them, and it will read it. It will read it when it receives a signal to read. So, yeah, I'm very sorry because we built RAM and it took me ages to do this. I just kept on looking at my schematics like, what the flip does that do? Oh, we're dealing in redstone, not bloody electricity. We don't need power because redstone generates its own bloody power. So yeah, I will not be doing tutorials. I'm very sorry, but it will take hours. and some other people on YouTube do tutorials. So yeah. But thank you for watching. Hit that subscribe button, like, do all that fun stuff to make me feel happy. And yeah, I'll see you in another episode of Minetech. Wait, before I go, I've also been, after this, I've been planning another series, which if you look in my playlist, you might have seen. It's called Minecraft Artificial Intelligence. And that's what I'm going to say.